Assalamualaikum warahmatullahi wabarakatuh. Pagi ni kita dah kuliah kimia untuk chapter 2, tajuk Thermochemistry, dan kita akan cover dua subtopik iaitu 2.1, apa nama? Chapter apa tu? Concept of enthalpy dan juga 2.2 Calorimetry. Jadi sebelum kita mulakan kuliah yang saya akan serahkan hari ini akan dikendalikan oleh Puan Suzila. Hari ini sebelum tu saya nak share lah kenapa chapter 2 ni kita ajar dahulu, sebab justifikasinya ujian amali kamu adalah dalam topik chapter 2 ni. Jadi nanti kita akan belajar chapter 2 dulu, habis chapter 2 dari kuliah, begitu juga dengan tutoran dan amali, baru kita masuk balik chapter 1. Okay, so tanpa melengah masa lagi, okay, saya bagi Puan Suzila lah untuk meneruskan kuliah. Ada soalan boleh tanya dekat dia punya ruangan chat.
Okay, Assalamualaikum, selamat pagi. So for today, okay, kita akan tengok chapter 2 Thermochemistry. Okay, Thermochemistry. So for this 1 hour, we try to cover 2.1 concept of enthalpy and 2.2 calorimetry. Tak jalan. Okay. So for 2.1, there are learning outcomes that we need to achieve for today. At the end of the lesson, students should be able to explain endothermic, exothermic reaction using complete energy profile diagram. And then students should be able to state standard condition of reaction and define the following terms: enthalpy and standard enthalpy. And the last one is students should be able to define and write thermochemical equation for each enthalpy below, which is formation, combustion, atomization, neutralization, hydration, and solution or dissolution. Okay, there are some important terms that you need to know before we proceed this subtopic, which is heat. Okay, heat is energy transfer between two bodies of different temperature. Okay. And then system is any specific part of the universe. And the last one is surrounding. Stop. Oh, sini je. Nampak? Okay, sebentar ya, ada gangguan sikit teknikal.
Jadi Puan Suzila, yang thermochemistry ni dia berkisar tentang apa sebenarnya? Kalau kita tengok daripada konsep kita nature kita sekarang ni, surrounding kita.
Okay, dia lebih kepada kita nak tengok macam mana perubahan tenaga tu berlaku, dan kita nak tengok jugalah beberapa jenis tindak balas. Okay, tindak balas yang melibatkan terdapat perubahan tenaga, sama ada tindak balas itu berlaku dalam keadaan endotermik ataupun exotermik.
Okay, baik.
Saya boleh share. Ya.
Sekejap ya.
Okey, kita sambung. Maaf atas gangguan teknikal tadi, kita ada gangguan sikit. Okay, so for 2.1, konsep entapi, students should be able to explain endothermic, exothermic reaction by using energy profile diagram, and then students should be able to define the terms of enthalpy and standard enthalpy. And the last one is students should be able to define and write thermochemical equation for formation, combustion, atomization, neutralization, hydration, and solution or dissolution. Okay, so before we go for more detail about this subtopic, there are some important terms that you need to be familiar, which is heat. Okay, heat is energy transfer between two bodies at different temperature. And then system is any specific part of the universe. And the last one is surrounding. Okay, surrounding is everything that lies outside the system. Okay, so for example, here we got orange solution in the conical flask. So we consider orange solution in the conical flask as the system, and the surrounding involved in this situation, we can say that anything else then orange solution is the surrounding, which is flask and the other apparatus outside the orange solution. Okay. So next, system. Okay, there are three types of system. We have open system, closed system, and isolated system. So what is open system? System that can exchange mass and energy with its surrounding. So dalam open system akan berlaku perubahan jisim dan juga tenaga. Okay, for closed system, system that allow exchange energy with surrounding, so means dalam closed system akan terdapat perubahan tenaga. In isolated system means the system that does not allow exchange either mass or energy with its surrounding. So dalam isolated system takkan berlakulah perubahan tenaga ataupun jisim. Okay. Next, what is thermochemistry? So thermochemistry is the study of heat change in chemical reaction. So most of chemical reaction involve absorb or release energy. Okay, there are two types chemical reaction, which is exothermic and endothermic. So for exothermic reaction, the temperature of system is hotter than surrounding. So in exothermic reaction, dia akan berlaku release heat from the system to the surrounding. So when the system release heat to the surrounding, the temperature of the system decrease. Okay. So for endothermic reaction, the temperature of the system is cooler than the surrounding. So in endothermic reaction, heat is absorbed. Okay, heat is absorbed from surrounding. Then we can observe that the temperature of the system should be increased lah. Okay. And then now we want to take a look what is the characteristic for exothermic reaction. Okay, so for exothermic reaction, enthalpy of product always smaller than enthalpy of reactant. And then the value of delta H always negative. Okay, why delta H is negative? Because from the formula, we can calculate the delta H. The formula of delta H is equal to summation of enthalpy for product minus summation of enthalpy for reactant. Okay, so in this case, for endothermic, enthalpy product smaller than enthalpy reactant. That's why we will get the delta H value is negative. Okay, delta H value is negative since enthalpy for product smaller than reactant. So in this case, energy is released from the system to the surrounding. Okay, next, now we want to draw, okay, we want to learn how to draw energy profile diagram for exothermic reaction. So consider for the following reaction, we have reactant A react with reactant B to produce product C, and delta H given is negative. Okay, negative means exothermic. And then what we want to do now, we need to draw the axis first. Okay, so we need to draw y axis and x axis, and then we need to label the axis. For y axis, we label as enthalpy, and then for x axis, we can label as reaction progress. Okay. So, since we have learned the characteristic for exothermic reaction, which is enthalpy of product always smaller than enthalpy of reactant, and then we can draw the diagram like this. Okay. Okay, untuk reactant greater than product, and then we need to label. Okay, what is the reactant involved? For this case, our reactant is A, gas, plus B, gas, and then the product is C. So we just write down the reactant and product involved, and then of course we need to label the delta H. Okay, delta H given negative. So where is delta H? Delta H is the difference between enthalpy product and reactant. Okay, so you need to label like this. Okay, show the arrow here and then label delta H equal to negative. Okay, so delta H negative against delta H negative refer to the energy released from the system to the surrounding. Okay, next we take a look for the characteristic of endothermic reaction. Endothermic reaction is characteristic dia enthalpy of product greater than enthalpy of reactant and delta H positive value. Okay, so like the formula for delta H, like I just informed before, delta H equal to summation of enthalpy product minus summation of enthalpy reactant. So in this case, enthalpy product greater than enthalpy reactant, of course delta H we will get value positive. Okay, so the positive value here show that the energy is absorbed by the system from the surrounding. Okay, now we want to draw energy profile diagram for endothermic reaction. Okay, energy profile diagram for endothermic reaction where we need to draw the axis first, y-axis and x-axis. So y-axis is enthalpy, x-axis we can label as reaction progress or reaction pathway. Okay, and then we draw the enthalpy product greater than reactant. So means here we need to draw reactant and then product. Okay, then we label reactant and product involved. Reactant gas plus B gas, product C gas. Okay, so then we need to show where is delta H. Delta H is the difference between product and reactant. Then we can label delta H here has a positive value since it was endothermic reaction. Okay, positive value. So positive value show that the energy is absorbed by the system from the surrounding. So another terms that you need to be familiar in this subtopic is energy. Okay, energy is the ability to do work and the unit for energy is a unit kilogram, meter squared per meter squared or joule. So in chemistry normally we use joule. And then enthalpy. Enthalpy is one of the type chemical energy, and enthalpy is referred to the heat content of a system or total energy in a system. Okay, enthalpy of a system cannot be measured. So that we have new terms here. We have enthalpy of reaction. Okay, enthalpy of reaction. So what is enthalpy of reaction? Enthalpy of reaction is the summation of enthalpy product minus enthalpy summation of enthalpy reactant. Okay, so enthalpy of reaction show the enthalpy change associated with a chemical reaction, means difference between enthalpy product and enthalpy of the reactant. Okay, so the symbol of enthalpy of reaction is delta H. Okay, symbol for enthalpy of reaction is delta H, and standard enthalpy means the enthalpy change for a particular reaction that occur at 298 Kelvin and 1 atm. Okay, so standard enthalpy, the symbol is delta H node. Okay, so once awak nampak node ni, maksudnya dia dalam keadaan standard. So what is different enthalpy of reaction and standard enthalpy? Difference dia, enthalpy change at standard condition means kat sini tindak balas awak berlaku pada 298 Kelvin. 298 Kelvin ni equal to 25 degree Celsius and 1 atm. Okay, 1 atm. So 298 Kelvin and 1 atm, we also call that as a standard state ataupun standard condition. Okay, this is the main part in 2.1. Okay, in 2.1, you must be familiar and know how to write the thermochemical equation for formation, combustion, atomization, neutralization, hydration and solution. Okay, so we will go through by this type of enthalpy one by one, and then we learn how to write, okay, the correct way how to write the chemical equation, thermochemical equation. So the first one is enthalpy formation. So the symbol for enthalpy formation is delta HF. F subscript F here for formation. Okay. So what is enthalpy formation? Enthalpy formation is the change of heat when one mole compound is formed from its element at their most stable state at stated condition. So stated condition dekat sini maksudnya pada suhu dan pressure yang dinyatakan lah. Ini maksudnya not include standard state. Okay, dia bukan pada standard state. So for example, stated condition for the reaction given 100 degrees Celsius and 1 atm. Okay, so 100 degrees Celsius, 1 atm given by enthalpy formation for H2O equal to negative 289 kilojoule per mole. Okay, so standard enthalpy formation for any element in its most stable state form is 0. Okay, for any element at stable state kat sini maksudnya pada keadaan asal dia lah. Contoh oksigen stable state dia adalah dalam O2, wujud dalam bentuk dui molecule and phase gas. Okay, so delta H formation for O2 gas is 0. Sebab dalam keadaan asal memang dia dah O2, jadi formation dia pun akan jadi sama dengan kosong. Sama juga delta H formation for sodium. Okay, sodium metal. Okay, metal. Jadi for sodium, delta H formation for sodium also equal to 0. Okay, now we want to learn how to write thermochemical equation for enthalpy formation. Okay. So in order to write the thermochemical equation, we need to highlight, okay, important part in the definition. Okay, so for enthalpy formation here, first thing that you need to highlight here is change of heat. Okay, so at different types of enthalpy, there are different definition here lah. So maybe you will found some reaction release heat or absorb heat. Okay, so this part you need to highlight. Okay, so for formation, it involves change of heat. That means it could be positive or could be negative. Okay, so when one mole compound form, this is second thing that you need to highlight. One mole compound form means that it refer to the product. Okay, dia merujuk kepada produk. Okay, from its element at their most stable state. From its element, from their most stable state, here means dia punya reactant dia lah. Daripada mana? From its element at their most stable state. So, for example, here we have H2O molecule. Okay, we have H2O molecule, and then H2O. Now we want to discuss about delta H formation. So formation of H2O means H2O here need to be 1 mole lah. Okay, 1 mole. And then we take a look. In H2O molecule, we have hydrogen atom and oxygen atom. Okay, so from this, we need to identify stable state for each atom. So hydrogen, stable state for hydrogen is in dui molecule, H2, and the phase is gas. Okay, oxygen also dui molecule and the phase is gas. So that one is the element at their most stable state. Okay, element at most stable state. So for formation of H2O, we can write like this. H2 gas plus O2 gas to produce 1 mole H2O. Okay, so be alert. Once you have set up like this, you need to check whether the equation balance or not. Okay, so we take a look for hydrogen. Hydrogen here 2. We have 2 hydrogen on product side. Okay, now we take a look at reactant. Reactant also we have 2, so hydrogen is balanced. Okay, and then oxygen. Oxygen, okay, oxygen here on the product side we have 1 mole oxygen, but at the reactant side we have 2 mole oxygen. Okay, so oxygen does not balance. We need to balance oxygen, but we must make sure the H2O here 1 mole. So how to maintain H2O here become 1 mole? We just need to add 1/2 in front of oxygen. So 1/2 times 2, we will get 1. Okay, so this is equation for enthalpy formation of hydrogen. Okay, next example CO2. Okay, for CO2, we identify the element that involved in CO2. In CO2, we have carbon and oxygen. So for carbon, stable state dia, stable state for carbon, carbon solid. Okay, stable state for oxygen, oxygen O2 gas. Okay, and then we write down on the reactant side, carbon solid plus oxygen gas. Okay, carbon solid plus oxygen gas. And then we check whether the equation is balanced or not. Check for carbon. Carbon, reactant 1, product 1. Okay, balance. Oxygen, reactant 2, product also 2. So for delta H formation of carbon dioxide here, the equation given is balanced. Okay. Now we check. Okay. Take a look the reaction given. Okay. Given H2 gas plus O2 gas to form 2H2O liquid, and the enthalpy formation here -572 kilojoule. Is it correct? Okay, take a look. Is it the thermochemical equation given correct or not? Can we define the equation as delta H formation? Okay, so if we take a look, the definition of enthalpy formation, it must be 1 mole compound form. But here we have 2 mole compound form. So when here 2 mole, therefore the equation is does not correct. Okay, you need to make sure the product form is 1 mole. Okay, so the question given is not delta H formation. Okay, next we have enthalpy of combustion. Okay, enthalpy of combustion is the heat release when 1 mole substance is burned completely in excess oxygen. Okay, so here we can see that for combustion involve heat release, and 1 mole substance here is referred to the reactant. Okay, refer to the reactant. Therefore, if you want to write the equation for enthalpy combustion, you must make sure then the reactant is 1 mole. Burn completely in excess oxygen, that means your reactant will react with oxygen. Okay, so this example for enthalpy of combustion. Okay, so enthalpy of combustion, 1 mole substance here, that one is substance nawak. Okay, substance burn in excess oxygen, so the product is CO2. Okay, the symbol for enthalpy of combustion is delta Hc. Okay, what is different between enthalpy of combustion and standard enthalpy combustion? Standard enthalpy combustion, okay, for standard enthalpy combustion, you just need to highlight, okay, standard state in the definition. Definition dia sama, cuma awak kena top up dengan standard state. Okay, so standard enthalpy combustion, heat release when 1 mole substance is burned completely in excess oxygen at standard state. Standard state means 25 degrees Celsius and 1 atm. Okay, and 1 atm. So symbol also you can see untuk standard enthalpy combustion, dia ada delta H note C. For enthalpy combustion, delta Hc only. Okay, so we take a look here. For carbon, when burned in excess oxygen, we get product as carbon dioxide. Okay, for methane CH4, burn in excess oxygen, we get carbon dioxide and water. Okay, so how could you determine the product form? Okay, it depends on the substance that you use. Okay, for example, if you have hydrogen as a reactant, okay, hydrogen as reactant, and hydrogen is, okay, react with oxygen in excess, okay, the product form is only water. Okay, product form is only water. Negative value lah, for example. So the product depends on the substance. If your substance contain carbon and hydrogen, you will get product carbon dioxide and water. But if the substance only have carbon, you will get carbon dioxide as product. Same goes to hydrogen. Okay, the substance only contain hydrogen, then the product you will get H2O. What about metal? Metal, for example, magnesium. Okay, magnesium solid. When we react in excess oxygen, we will get metal oxide. So in this case, we will get magnesium oxide. See, here no carbon dioxide, no H2O. Why? Because your substance only have metal. Okay. And then enthalpy atomization. So enthalpy atomization symbol is delta H A, delta H A. So what is enthalpy atomization? Means heat absorbed. Okay, heat absorbed when 1 mole gaseous atom is formed from its element. So 1 mole gaseous atom form means ini dekat bahagian produk lah. Produk awak pula akan jadi 1 mole. From its element, dia lebih kurang macam formation tadi. Stable state element. Okay, for example, sodium. Sodium stable state dia solid, and then when sodium undergoes atomization, sodium will convert to gas. Okay, gaseous atom. Gaseous atom means dalam phase gas, and then atom means dekat sini dia dalam keadaan single lah. Okay, same goes to chlorine. Chlorine stable state Cl2, Cl2 gas, but when we atomize chlorine gas, we will get chlorine atom. Yeah, can you see that the difference? Cl2 becomes Cl gas. So that means in gaseous atom. Okay, so we need to balance the equation. That's why we put 1/2 in front of Cl2 to make sure the balance, the equation is balanced. Okay, so 1 mole here we need to highlight on the product. Okay, and next we have enthalpy neutralization. Okay, enthalpy neutralization. Okay, what is mean by enthalpy neutralization? Heat release when 1 mole water is formed from neutralization HCN base. So delta Hn is referred to the number of mole H2O form. Jadi kat sini example for reaction between HCl and NaOH, sodium hydroxide, to produce NaCl and H2O. So when we balance equation, this is balance equation. Then for H2O, we need to make sure in 1 mole. Okay, 1 mole for delta Hn. Another example, maybe you can use H2SO4. H2SO4 equals plus base potassium hydroxide to form potassium sulfate. Potassium sulfate equals plus water. Okay, so when you have write the reaction, you need to make sure the equation is balanced. Then when we check, we need to write, okay, to add 2 in front of KOH and also H2O. Okay, but remember enthalpy of neutralization defined for 1 mole. So this one you need to convert become 1 mole. How to convert jadi 1 mole? Divide by 2. We can divide whole equation by 2. So we will get 1/2 H2SO4 equals plus KOH equals to form 1/2 K2SO4 equals plus H2O liquid. So this is equation for delta Hn. Okay, delta Hn. Enthalpy hydration. So enthalpy hydration is measure heat change when 1 mole gaseous ion is hydrated in water. So for enthalpy hydration, heat change 1 mole gaseous ion means here you have ion in gaseous state, and hydrated in water means you have ion in aqueous state. Okay. Here, the changes only occur at the phase of the substance. Okay, phase of ion awak. Sekarang ni kat sini kita boleh nampak sodium plus ion in gaseous state when undergo hydration, it will become sodium plus aqueous. Okay, same goes to chloride ion. Chloride ion gaseous state when undergo hydration, it will become chloride ion in aqueous state. Okay, so hydration just involve changes in phase. Okay, next, solution. Enthalpy solution. So enthalpy solution is defined as heat change when 1 mole substance dissolved in water. So 1 mole substance here in solid state. Dissolved in water means you will get ion. Okay, you will get ion in aqueous phase. Okay, for example, KCl solid dissolved in water, we will get K plus aqueous plus Cl minus aqueous. Same goes to MgCl2 solid. Okay, when hydrated in water, when dissolved in water, you will get Mg2 plus aqueous plus 2Cl minus aqueous. Okay, so the symbol for enthalpy solution is delta HSOLN, short form for solution. Okay, delta HSOLN. Okay, so now we want to take a look tips and tricks for thermochemical equation. Okay, thermochemical equation, when we write the thermochemical equation, we must make sure that the phase is labeled. Okay, so you need to state the phase. Phase is insist for this topic. Okay, phase, for example, whether it gas, liquid, solid or aqueous, you need to state clearly. And then you need also to put heat of reaction at the end of the equation. Okay, heat of reaction means here delta H, whether delta H is positive or delta H negative. Okay, so for example here we have methane react with oxygen gas. So we need to put the phase for each substance and then produce carbon dioxide gas and water. Delta H equal to negative 890.4 kilojoule. So delta H you need to put at the end of the equation. Okay, these two things will differentiate between thermochemical equation and chemical equation. So these two things is very important in thermochemical equation. Okay, normally for thermochemical equation, the question, the marks for the thermochemical equation are given 2 marks, will be given 2 marks. Okay, 2 marks means for the balance equation 1 marks, and for the delta H given at the end of equation is 1 mark. Okay, next. So for thermochemical equation, the special of thermochemical equation, we can calculate another reaction that relate to the thermochemical equation given. For example, here we have methane react with oxygen to produce carbon dioxide and water. Delta H given is negative. But when we reverse the equation, the value of delta H remains, but the sign, the sign of delta H will be changed. Okay, so kalau asal dia negatif, after reverse dia akan jadi positif. Kalau asal dia positif, After reverse dia akan jadi negatif. So ni specialnya thermochemical equation. Okay, another example here, H2O, given H2O solid, convert to H2O liquid, delta H given positive 6.01 kilojoule. And then if we reverse the equation, we will get the delta H value become negative 601 kilojoule. Okay, another example that we can use by using thermochemical equation is, let's say we have 2H2O solid become 2H2O liquid. So what about the delta H here? Okay, and then we just compare the given equation yang asal and then the one that we want to find the delta H. Here we can compare the number of mole, the coefficient for reactant and product is not same. Okay, like this one we have 2 mole, here we have 1 mole. So what that mean? That mean you need to multiply by 2 the whole equation in order to get new delta H. Okay, so after multiply by 2 we can get the answer is the sign is still remain same because the ration is we don't have to reverse the equation, so the sign is same but the value will be double lah. Okay, dia akan jadi positif 12.02 kilojoule. Okay, so this concept you will apply in 2.3. Okay, in 2.3 you will use this concept again. Okay, in algebraic method. Okay, next one. Okay, ni exercise kita tak sempat dah nak go through exercise. Can do by your own. Now we go to 2.2 calorimeter. In calorimeter, what you need to know in calorimeter is the definition of heat capacity and specific heat capacity, and then calculate heat change. Okay, for a constant volume calorimeter and calculate heat change constant pressure calorimeter. Okay, so what is calorimetry? Calorimetry is method used in lab to measure heat change, and the apparatus that we use we call as calorimeter. So there are 2 calorimeter. So 2 calorimeters, simple calorimeter and bomb calorimeter. So for our lab, we just have a simple calorimeter. You will use this simple calorimeter in your experiment. Okay. So what is the setup for simple calorimeter? Simple calorimeter we can set up by using styrofoam cup. Okay. So the outer styrofoam cup insulate the reaction mixture from the surrounding. So from this we can assume that no heat loss to surrounding, and then heat release by reaction is absorbed by calorimeter and the solution. Okay, solution in the styrofoam cup. And then bomb calorimeter. Okay, for bomb calorimeter, it has specific part for the reactant to react. And then when the reaction is set off, heat that is liberated is absorbed by the bomb and the water. Okay. So kita tengok sikit sini. Important terms in calorimeter, of course, specific heat capacity and heat capacity. I'm sure you ever heard this term in physics, right? Okay. So specific heat capacity is the amount heat required to raise temperature of 1 gram substance by 1 degree Celsius. Okay. Heat capacity is the amount heat required to raise temperature of a given quantity substance by 1 degree Celsius. So from the unit we can C specific heat capacity, ni simbol dia C kecil. Okay, symbol for specific heat capacity and the unit is joule per gram per degree Celsius. While heat capacity symbol dia C besar and then the unit is joule per degree Celsius. Okay. And then we have basic concept. Okay, this basic concept you will use in your experiment next week. Okay, so basic concept, basic principle in calorimeter, heat released by reaction equal to heat absorbed by surrounding. So surrounding here, okay, surrounding here may refer to the calorimeter itself. So if the surrounding is calorimeter itself, we can calculate heat release by using formula Q equal to C delta T. So C here for heat capacity of calorimeter. Or if the question given mass for calorimeter and specific heat capacity for calorimeter, so you can use this formula, mass calorimeter, specific heat capacity for calorimeter and delta T. Okay, or your surrounding may include to solution. Solution, we just use formula Q equal to mass solution, specific heat capacity for solution and delta T. Okay, or surrounding involve both, whether water or solution and calorimeter. So we can use formula Q equal to mass untuk water delta T plus mass C delta T. Okay, that one is for calorimeter. So the value for specific heat capacity of water is a constant. C for water is constant and the value is given in front of your book. You can refer in front of your book. The value is 4.18 joule per gram per degree Celsius. Kalau tak ingat boleh tengok kat depan. Okay. So kita tengok example untuk calorimeter. So calculate amount heat release in a reaction in an aluminium calorimeter with mass 3087 gram and contain 1700 ml water. So the initial temperature of calorimeter is 25, increase to 27.8 degree Celsius. So given in the question also specific heat capacity of aluminium. That means C kecil C kecil untuk aluminium. And then specific heat capacity of water, C for water. And water density. Why it is given water density? So water density we can use to relate with volume water given. So from volume water given we will get mass of water. Okay. Okay, the density water. So we know the formula of density. Density water equal to mass water divided by volume water. So density water given 1.0 gram per ml. Mass water we want to find it, and then we have volume of water. Volume water given 1700 ml. So we can get mass water equal to 1700 gram. Okay, that's why it is given the value of water density. Actually we can use the value to find the mass of water. Okay. So, initial temperature and final temperature given, so we can calculate the delta T. Delta T value always positive. Okay. And then the solution is heat released by direction equal to heat absorbed by water and heat absorbed by calorimeter. So we need to total up this one. Okay. Here we have formula mass for water, C water delta T. Mass water we get from density 1700 gram. Density C water is constant, okay, given in the question. And then delta T yang kita calculate tadi lah, final tolak initial, okay, 2.8. So for aluminium calorimeter, given mass untuk calorimeter, so we just substitute mass calorimeter, specific heat capacity for calorimeter, and then delta T. Okay, we just substitute the value. Delta T same for duration, delta T is same, and then we get Q equal to 24.7 kilojoule. Okay, 24.7 kilojoule. Okay, so last one. Okay, last one. This is example for neutralization reaction where given here 25 ml 1 mole per dm cube HCl and 25 ml sodium hydroxide, and then given also initial temperature and final temperature and specific heat capacity for solution, also density for solution. Okay, so from here the question asks to find the enthalpy of neutralization, means delta Hn. Okay, delta Hn. So what we need to do, okay, we need to find the Q first. Q released by duration. So in this case, surrounding involve only solution. Why solution? Okay, because in the question we just only have info for solution, no calorimeter or no others lah. So here we can use formula Q equal to mass solution, C solution and delta T. Mass solution means here acid plus base. Okay, so tadi acid kita HCl 25, base kita pun 25, dapatlah 50 ml. And then 50 ml we relate with density, so we get lah the mass of solution in gram. Okay, specific heat capacity untuk solution given in question, and then delta H we can minus final minus initial, so we get delta T 6.5, and then kita dapat Q. So from direction we need to write down the equation involved, and then from the equation we need to find the number of mole HCl. For this case, number of mole HCl is equal to number of mole NaOH, since the volume used and molarity is the same, and from the stoichiometry we can conclude that the number of mole HCl is equal HCl NaOH mole equal to 0.025. Okay, and then water. Why we need to find the number of mole water? Because the definition of delta Hn itself. Delta Hn itself defined when 1 mole water form. Okay, 1 mole water form. So we need to find number of mole water form from direction. Number of mole water form from direction is 0.025. Okay, 0.025, and then we need to calculate delta Hn. So this is by using stoichiometry, or you can use formula delta Hn equal to negative Q over N H2O. Okay, so Q yang kita calculate depan tadi, dia value dia akan jadi negatif sebab heat release, and then mole water is mole water that we calculate from stoichiometry, and then we will get same answer like this. Okay, kita akan dapat jugalah 54.34 negatif. Okay, negatif. Why negative? Definition delta Hn itself, heat release. Okay, heat release. So delta Hn always negative. Okay, that's all. So here some enhancement exercise, okay, for lecture today. Then all of you need to submit this form, okay, before 4 p.m. Okay, 4 p.m. Okay, so this is as evident for your attendance today. Okay, thank you.
Okey, terima kasih Puan Fazila. Okey, kita jumpa lagi pada Rabu minggu hadapan dengan masih dalam topik thermochemistry tapi subtopik yang lain lah. Okey, sehingga bertemu kembali. Terima kasih kerana sudi menonton. Assalamualaikum, salam sejahtera.